What's up everyone, Patrick here, welcome back. In this next question, we're told two ordinary set of dice are tossed. So an ordinary set of dice, they're numbered 1 to 6. And we have to find what is the probability of these scenarios here, that the sum is greater than 8, the product is 6, the sum is less than 10, the sum is greater than 12, and the sum is a multiple of 3. So before getting into these specific scenarios, how many total possibilities are there when you throw two dice? Well, the first dice can take one of six values, right? So it could be 1, 2, 3, 4, 5, 6. So you could represent this with a tree diagram. So that's the first dice. It could be one of these values. Then the second dice can be, again, either 1, 2, 3, 4, 5, 6. And so there would be 6 branches coming out of each of these branches for the possibility of that second dice. And so the total number of possibilities would be 6 times 6. Right? 6 to the power of 2. So 6 different values for the first dice, 6 different values for the second dice, so 36 would be the total number of possibilities. And we need that when we're going to be calculating the probability, because then we're going to have to count how many possibilities are in each of these conditions and then take them as a fraction of the total number of possibilities. That's how you calculate probability. So what we can do here is let's represent all of these possibilities. I'm still staying with this 36 here as coordinates. So the first dice can be 1 and then 1. First dice can be 1 and then the second dice can be 2. 1, 3, etc., all the way to 6 and 6. So there would be 36 of these. So that's how I'm going to represent the number of possibilities for each of these different conditions here. I'm going to represent them like this in this coordinate format, where the first coordinate is the value of the first dice, the second coordinate is the value of the second dice. So there's sum being greater than 8. What are the different possibilities that can happen? So you can have, let's say the first dice is 6, well, the second dice can be 3. Or the second dice can be 4, could also be 5, it could also be 6, like that, right? Notice how the sum, 6 plus 3, 9, 10, 11, 12, all those sums are greater than 8. But notice that we can also switch the order. In this case, the order matters, right? That's why we multiplied over here. So notice that we can switch this. This could be 3 and 6. So the first dice can take a value of 4. Second dice can take a value of 6. First dice can take a value of 5. The second dice can take a value of 6. Notice that these sums as well are going to be greater than 8. Notice this 6 and 6, we can't flip that because it would be the same thing. Right? 6 and 6, there's only one possibility for that to happen. To get a sum of 12, there's only one way that could happen, and that's if it's 6 and 6. You can't, if you switch this, it'll be 6 and 6, it'll be the same thing. So you'd be double counting that possibility. All right, so that's if we're dealing with 6. Now, what about if we're dealing with 5? So let's say that the first dice has a value of 5. Well, notice that the second dice would have to have a value greater than 3 because we have a sum that's greater than 8. Not greater than or equal to 8, but greater than 8. So then the second dice would have to take a value of 4. So that would give us 9. We could also have 5 and 5, which would give us a sum of 10. And then notice 5 and 6 we already counted over here. So you got to be careful not to double count, right? So we wouldn't include that over here. So 5 and 4, 5 and 5 work. Notice which of these can we reverse? We could reverse the 5 and 4, right? We could also have 4 and 5 like that. The 5 and 5, we can't reverse that. Now we have 6, 5. What about 4? Well, the only way 4 can work is if we have a 5 or if we have a 6, but notice we already counted both of these. This we counted here, this we counted over here. And then with a 3, the only way that's going to work is if we have a 6, but 3 and 6 we already counted here, and then 6 and 3 we counted there. And then 2 won't work because to have a sum greater than 8, you'd have to have 2 and 7, but then the value of 7 is not on the dice, right? So these would be all of the different scenarios here. And you may list them in a different way intuitively, just as long as you're getting these same elements with this condition here. And so how many elements are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? There's 10 elements, and so the probability for A would be 10 over 36, and then you could reduce this to 5 over 18. Right? So that would be the probability that the sum of 2 dice is greater than 8 if you toss them. So that's the answer to A. Now what about B? The product of both values of the dice would be 6. So how can that happen? Well, you can have 1 and 6. You can have 6 and 1. You could have 2 and 3. You could have 3 and 2. And then I believe that's it, right? 4 won't work, right? Because 4 times 1 is 4, 4 times 2 is 8. 4 is not a multiple of 6. The only multiples of 6, another way to look at this, is 1, 2, 3, and then 6. And then these combinations here took into account those multiples. And then there's no, let me think here, there's no other way, right? So in this case, there's 4 different ways that this could happen where the product would be 6, and it would be those 4 different ways there. So the probability would be 4 over 36, and if you reduce that, it'd be 1 over 9, like that. So that's the answer to B. Now, what about the answer to C? The sum is less than 10. Now, in this case, I feel it's easier to do it the indirect way. So you can either, to get this probability, you could find the number of possibilities where the sum is less than 10 and take that over the total number of possibilities, which would be 36. So you could count all of those, but I feel like it's easier to do it the indirect way where we take 1 minus where the sum is greater than or equal to 10 over 36. Right? The probability of all of these is just 36 over 36, which is 1. So the sum either has to be less than 10 or greater than or equal to 10. And so adding this and this would give us that 1. So to get this, we can either do it directly like this, so count up all the possibilities, so like 1 and 1 would work because that would be a sum of 2 which is less than 10, or 1 and 2, 2 and 1. But we're going to have a lot more possibilities here to deal with and to think of than all the possibilities where it's going to be greater than or equal to 10, right? Because if we look at all the possibilities where the sum is greater than or equal to 10, how many would there be? Well, it would be, what, 5 and 5, would work. Let's start with a sum of 10. So 5 and 5, 4 and 6, 6 and 4. Those would be the only possibilities for a sum of 10. So like 3 and 7 wouldn't work because 7 is not on the dice. So these would be all the possibilities where the sum is 10. What about a sum of 11, which is still greater than or equal to 10? That can only happen as 6 and 5, 5 and 6. There's no other way that it can happen. And then a sum of 12 can only happen one way, 6 and 6. Right? So there's 1, 2, 3, 4, 5, 6 possibilities for the sum being greater than or equal to 10, which means that if we counted all the possibilities where the sum was less than 10, you would actually get 30. It would be 36 minus these 6 over here. So it's easier to do it the indirect method. So what you would do, there's 6 possibilities of this happening, so it would basically be 1 minus 6 over 36, which would be 1 minus 1 over 6, which would be 6 over 6 minus 1 over 6, which would give us 5 over 6. All right, so that would be the answer to C. Or if you did it the other way, if you did it this way and actually listed out all 30 elements, then it would be 30 over 36. And then this here reduces to 5 over 6. So whichever way you do it, whether this way or this way, final answer for part C is 5 over 6. Now moving on to part D, the sum is greater than 12. Well, notice that there's actually no ways that that could happen, because what's the max sum? The max sum would be if both dice took the highest value of 6, the sum of that is 12. So that's the max sum. So a sum greater than 12 is not possible. There's no possibilities for that. So it would be 0 over 36. So a probability of 0. No chance of that happening. And then the sum is a multiple of 3. So in this case, I feel like it's easiest to just write out the multiples of 3. So multiples of 3 are 3, 6, 9, 12. Next one would be 15, but remember the max sum is 12. So the sum is a multiple of 3. You can't get a sum of 15. So these would be the different possibilities for the sum to be a multiple of 3. So starting with a sum of 3, how many ways can this happen? Well, it could be 2 and 1 or 1 and 2. Right? There's no other way that a sum of 3 can happen. What about a sum of 6? Well, this could be 3 and 3. Could also be 2 and 4. It could be 4 and 2. It could be 5 and 1, 1 and 5. Those are all the possibilities for a sum of 6. What about a sum of 9? That would be 6 and 3, 3 and 6. 5 and 4 would work as well, 4 and 5. And then I believe that's it. 4 different possibilities for a sum of 9. And then a sum of 12, there's only one possibility for that, 6 and 6, like that. Right, so these are all the different possibilities where the sum would be a multiple of 3. So how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So part E would be 12 over 36, and then you could divide both the numerator and denominator by 12, which would give you 1 over 3. Right? So that would be the probability that the sum of these two dice is a multiple of